Hello everybody, my name is Sébastien Grignard, and in this presentation I will tell you about the software I work on currently, Tracim. But first, let me introduce myself a bit. I have been working in the software industry since around 20 years, mainly as a software developer and architect in several companies. I have been a supporter of free software since my student days, and nowadays I'm working for a company named Algo, whose main goal is to prosper by editing free software. Our main product is Tracim, a collaboration tool which aims to be easy to use for any kind of public. First, I'll do a quick tour of Tracim principles and of its main features. Then, I'll present its architecture, which is classical for a web application, a front-end part and a back-end part. Finally, I'll detail one of the key technical features of Tracim, its mechanism for server-pushed updates. So first I'll present a little bit the features. All Tracim users must have an account, so the first user experience is to log in. When logged in, a user is shown the list of spaces he is a member of. Spaces are a set of users and can contain contents. Members of a space can interact by creating contents, which I'll detail later. Member access rights are simple roles, reader or contributor, whose scope is a space. Space contents can potentially have any type. The user interface can vary based on the content type, but it also displays some common parts. For example, all contents are versioned, so you can directly see their history of modifications. They also have an associated comment thread displayed together with the history. A special kind of content named news can be used to easily publish simple information and have a discussion about it. All modifications on contents are recorded and users are informed of the changes in the notification panel, which is available in the interface's header. A user mention system is present, which emphasizes a notification if it includes a mention. A summary of the last modifications is available for each space and is called recent activities. There is also a search feature which allows users to easily find contents, spaces, or other users. This search feature is a full text search. The whole contents are indexed. All changes on contents, spaces, users are directly pushed to each connected user without the need of refreshing the entire interface. So now, the software architecture. Tracim's architecture is split into main parts, front-end and back-end. As you may have noticed, Tracim's front-end is a single-page web application. The graphical interface and state are managed with the React and Redux frameworks. The front-end is composed of a core application providing common features like the search interface, the list of spaces, and feature applications. This architecture allows customizing the display and tune the features for each content type. It makes Tracim modular and provides a standard configuration to enable or disable feature applications on a specific Tracim instance. Now let's present the backend architecture. The backend of Tracim is written with a Python language. The web, the web application component is based on the Pyramid framework, which is a helper to create WSGI applications. The database system can either be SQLite or PostgreSQL and is accessed through the SQL Alchemy ORM. Some in-house packages have been written to provide key features of the backend. The first one is Epic, which is a helper to create REST APIs. For example, it auto-generates an OpenAPI documentation directly served within Tracim. The other in-house package is Preview Generator. Preview Generator is an interface to create preview pictures of many file formats: Office files, videos, cameras, raw pictures, 3D modeling formats, and many others. Those two packages are maintained independently from Tracim and can be used in any Python application. So now I'll tell you about the components of the backend of Tracim. So the backend of Tracim, as you can see, is split in several components. The mail interaction components, which allows Tracim to send mails upon some actions and receive mails to comment contents. The agenda feature is provided by a Radical server integrated into Tracim, with the online edition of Office file is provided by integrating a Collabora online instance. The advanced search engine uses Elasticsearch. The access through the WebDAV protocol is an in-house component written with WSGI dev, and lengthy operation, for example sending of mails, content indexing, are managed through an asynchronous task queue based on RQ and Redis. Finally, the mechanism for server-pushed updates, called Tracim Live Messages, is implemented with Pushpin, and this is the subject of the next part of this presentation. So, what are Tracim Live Messages? Tracim Live Messages are created and distributed for every change on the main Tracim objects: users, spaces, contents. Each message describes one change, which can be a creation, an update, a deletion of an object. Tracim Live Messages are used by the front-end application to trigger its interface updates. They also are the base of the notification panel and the recent activities features. The Tracim Live Messages are distributed to clients by the Pushpin proxy. When a user logs in, the front-end application opens a connection with the server using the event source browser API. Then, all messages whose recipient is a connected user are sent by the backend to the front-end application, as you can see on this diagram. Pushpin is a reverse HTTP proxy that manages the long-lived connections needed for TLMs. From the point of view of the backend application, adding support for those connections only means to reply special HTTP headers to the initial front-end request. Those headers are interpreted by Pushpin to create the Tracim Live Message connection and link it to its channel. A channel in Tracim represents one user. Then the backend needs to send messages to pushpin channels when a modification, an event, is triggered by a database update. So you get a database update, and the messages are created in reaction to those, then dispatched by pushpin. As pushpin is a reverse proxy, it means that it is easily integrated in an existing web application. For example, the authentication in Tracim is still directly controlled by the web application as it would be for a classic HTTP request. Pushpin can use several long-lived connection schemes: WebSockets, long polling, server-sent events. We've chosen server-sent events for Tracim mainly because the functionalities they provide match our usage, which is a unidirectional sending of events, but also because the protocol remains standard HTTP, as opposed with WebSockets, for instance. Server-sent event also provides some level of standardization in the message sending protocol. This standardization means that several client libraries for many languages already exist, which improves the possibilities to integrate Tracim with other systems. So now I'll talk a little bit about our experience while implementing the Tracim live messages. So standard HTTP requests only require short connections between the client and the server. When the response is received, the connection can be closed. But the server-sent event connections we use for Tracim live messages should never be closed while Tracim's front-end application is executing. This means that a reconnection mechanism is needed because networking is unreliable by nature. We also had to find a solution to work around the limitation of the number of concurrent HTTP connections to one domain when using HTTP1. So first, the reconnection mechanism. The event source API has an integrated reconnection mechanism which is directly controlled by the browser. But this mechanism wasn't satisfying for our needs. Some connection loss situations aren't handled, and it's not possible to know the connection's state. So we implemented our own connection loss and reconnection mechanism on top of the event source API. This mechanism is based on a heartbeat system. Pushpin is configured to set heartbeat events on a regular interval. Then the front-end application considers a connection lost if the heartbeat message isn't received within a reasonable interval. The front-end interval is slightly longer than the back-end one to take network delays and processing delays into account. The object implementing the connection mechanism also maintains the connection state and signals when the connection is lost. This is used to display a message to the user in those cases. So now the second problem we encountered was the connection number limit with HTTP1. Most browsers limit the number of concurrent HTTP connections to one domain to 6 concurrent connections when using HTTP1. This is a problem for the server-sent event connections when a user opens many tabs connecting to the same Tracim domain. One way to avoid this limitation is to use the HTTP2 protocol, as the number of connections is then negotiated between the server and the client, defaulting to 100 in most cases. This is the first approach we've tried out when implementing Tracim live messages. In our infrastructure, Tracim is deployed behind an Apache reverse proxy, which is the SSL termination and provides HTTP redirections to the right Tracim's instance. So we needed to activate HTTP2 on this Apache instance, which is logically a small configuration change. At first, this solution seems to be okay. There were no more limitations client-wise. But when a number of clients were connected to one server, to our server, we observed that the Tracim Live Messages connections became unresponsive, or even that new browser tabs couldn't connect to the Tracim server. After a good amount of investigation, the conclusion has been that Apache's HTTP2 module had no problem with short-lived connections, but didn't work very well with long-lived connections required for Tracim Live Messages. Swapping Apache for another HTTP server, NGINX for example, was out of question, as it had too many implications and was considered to require too much work. So we decided to create a workaround in the front-end application instead. This workaround consists of sharing the Tracim Live Messages connection between all open browser tabs and windows. Browsers provide many ways to communicate between tabs, and one good API to do that is a broadcast channel API. Our implementation is using a library based on this API to only open one Tracim Live message connection per domain, then share broadcast the messages received on this connection to all tabs. This solution also has the good side effect of limiting the network usage, as messages are only sent once for each connected device. So, as you can see, implementing real-time UI updates and notifications in a web application like Tracim is not as easy as one could imagine. There are many interesting and unforeseeable aspects and challenges to it. Don't hesitate to check out our code or drop us a line at bonjour@tracim.fr if you are interested in more details. We also run a community instance of Tracim at community.tracim.fr where you can interact with us and other Tracim users in English, French, German, and Portuguese. Thanks for watching. I'll be glad to answer any of your questions just afterwards.
Okay, so thank you very much, Sébastien, for this talk. Now we'll be able to take some questions. So if you have any, don't hesitate to put them on the chat, and we should be able to answer it. So apparently now the streaming is going back to normal. So if you can. Thank you, Inky, for the documentation about Tracim. We have a nice question from Damko. So do you plan to translate Tracim.fr also in English?
There are plans to translate it in English. First, we started with French because we are a French company and our first customers are French, but we are
Okay. So then another question from Claudio. Tracim seems to be a good way to handle collaborative work for documents, but what about an integration with existing services like Nextcloud? Or Tracim is considered as an alternative? An integrations plan, maybe?
Okay, so first I'll answer for the translation in English. Yeah, there are plans to do it because we are trying to open a little bit more to the international, and worldwide public. So yeah, we have plans to do it, and in fact. Tracim is more like an alternative to Nextcloud. So it has its own storage backend. So there is no possibility to use Nextcloud as a backend.
Question about if you have any idea about the platform that you could use in order to do some community translations.
In fact, we started just recently to use a Weblate for the community translation. It's really in the early phases, but we've started to use Weblate. It's the hosted version. I'll drop a link in the chat. Okay.